I am Anil Kumar. Welcome to my series on vectors. We will now understand how to represent vectors. As a basic rule, vectors can be represented in words, in a diagram, or in symbols. Here are a few examples to understand the concept. Car traveling northeast with a speed of 65 kilometers per hour. So we are given the magnitude, which is 65 kilometers per hour, and the direction, which is northeast. I could represent this vector on a coordinate plane, for example, saying that, well, this is north for us, right? This is east. Northeast will be that direction. Okay. Now, if this length represents 65 kilometers per hour, this length represents the magnitude 65 kilometers per hour, right? Then this direction, which makes 45 degrees with east, will be representing the velocity vector, speed of 65 kilometers per hour, northeast direction. Is that clear to you? Then we have the second example, which is displacement of 10 meters east. Well, we'll make a different diagrams, but we could show it on this diagram itself. 10 meters east will be this arrow pointing towards east, and the length will give you 10 meters. Does make sense to you, right? Vectors could also be represented by an equation given here, which is vector A equals to 4 meters at a bearing of 200 degrees. Now, when we say bearing of 200 degrees, it means what? It means that we are looking at the angle from the north. So let me define what bearing angle is. So when we say bearing, then it is clockwise from north. Okay. Now bearing angles are always given to three places, right? So they're always given in three places. There will be written in 100 place, right? So angle of 200 degrees bearing means that from here, the angle is going to be 200 degrees. So this is 180 plus 20 more. So that should be 200 degrees, correct? So this is 200 degrees bearing. So we could represent vector A, which is 4 meters at a bearing of 200. So this could be our vector A, and the length will be proportional to 4 meters. Is that clear to you? Right? So that is how you show bearing angles. So again, bearing angles are measured clockwise from north, right? So this is your north. So it is measured clockwise from north. They are always written to three places in hundreds. Okay. V equals to 6 kilometers per hour at a quadrant bearing of from north 35 degrees east. Now this is another convention. When we talk about quadrant bearing, then we are measuring with either north or south, right? So we measure from north or south. In this case, it is saying from north 35 degrees east. That means 35 degrees east from north. So that could be your direction for 60 kilometers per hour. Does it make sense to you, right? So that is 35 degrees from north towards east. So that is how you will show that particular vector, correct? Force of 25 newtons at 30 degrees to the horizontal. So at times we also show vectors with horizontal. So it could be, for example, shown like this. So this is your horizontal plane and that vector. So this is at 30 degrees to horizontal, a force which has a magnitude of 25 newtons. 25 Newton. Does it make sense to you? So that is how you could make it represent this particular vector with horizontal. Now vectors could also be shown as OP, means here position vector. So when we write OP, we call this as a position vector, right? So OA from origin, that means, right? So if I have to show this vector 3, 4, then on a coordinate plane, we could do something like this. Let me just sketch it here for you. 3, 4 will mean 1, 2, 3, 1, 2, 3, 4, right? So this vector will be vector OP, right? So that is how you show the vector, position vector, on a coordinate plane, XY coordinate plane. The next one is an example of R3 in 3 dimensions. I, J, K are actually 3 quadrants, X, Y, and Z directions, correct? So that is how in R3 we represent our coordinates, X, Y, and Z. So let me show you how to represent the vector 2i minus 3j plus 2k. So 2i means move 2 units, 1 and 1, 2 units towards x direction, minus 3j, that is positive direction. So 1, 2, 3 minus 3j plus 2k means upwards, 1, 2. So the vector from origin to this place will represent OA. Does it make sense to you? So that is how you could show your vector in R3. Now, vector AB equals to 2, 3, we call this as a free vector. So anywhere on our plane we could represent, for example, A could be this point, right? So from this point, 2, 1, 2 units, and minus 3 means go down 3 units, 1, 2, 3 for example. So that could be your vector AB. Does it make sense to you? So these are free vectors. You could also show it from the center, which is the origin, keeping A at the origin O, then be 1, 2 and 1, 2, 3, right? So these vectors are free vectors. They will be all equivalent vectors. Perfect. The last one here given to you is PQ, and then we have a vector V. Now, PQ and V, we have shown it in 2 different forms. This is like a row, right? And that is a column. So vectors are also represented in rows and columns, and in this form, we normally use them in matrices and many solving simultaneous equations, for example, right? So especially in the column form, when we use vectors, we use them a lot of times in doing operations with vectors. Geometric vectors, or in the diagrams, we represent the vectors in the form of arrow diagrams. So all this which I was drawing so far are actually arrow diagrams. Does it make sense to you? So you can now see for yourself that most of the diagrams which we made included a straight line and a direction. Straight line gives you the magnitude and the arrowhead gives you the direction. This is called the tail and that is the head. And this is how you could represent the vectors in general, and we call them arrow diagrams. Now arrow diagrams where you can have same type of vectors, we will soon learn about position diagrams and vector diagrams, right? So velocity diagrams. So we look into position and also velocity diagrams in the coming units. But I hope that gives you a fairly good idea about how to represent vectors. So let's summarize. Vectors can be used in words, just as car traveling northeast with a speed of 65 kilometers per hour. In the form of a diagram, if I draw any vector, kind of like this, saying that this is going from a point A towards P, the magnitude is 65 and this direction being 45 degrees with the horizontal, which is normally represented as east, will be treated as northeast. Is that clear to you? So normally these vectors which are written in words can be represented in diagrams. We could also write them as symbols, since we saw different forms in which we could write this as symbols also. Does make sense to you, right? So we have seen how vectors are given in the form of bearing angles. In bearing angles, we have two types of bearings. One, which we represent with clockwise direction from the north, is called true bearing. And the other one, which is given in this form, is called the quadrant bearing, right? Vectors are also represented in the coordinate system using I, j, k. I and j and k are unit vectors along x, y, and z directions. We also represent vectors as rows and columns shown here. Now let's take up an exercise with few examples to understand all these concepts. Question 1 for you is, represent the following vectors with arrow diagrams. A, weight of 80 newtons. B, displacement of 200 meters west. C, OP is minus 25. D, displacement from A, which is 2, 3, to B, which is 0, minus 3. Okay. So let's begin with the first one, weight of 80 newtons, right? So weight of 80 newtons with arrow diagram, you can have a vertical line acting downwards. And this vertical line length will represent the magnitude 80 newtons. And the direction is going towards south. So a downward line will represent weight because it is a force of attraction towards the center of the earth. P, displacement of 200 meters west. So west is direction towards the left side. So this represents the length itself represents 200 meters, right? So and the direction is west. So that is how you could represent displacement vector 200 meters west. Now let's look into the position vector OP. So when I'm saying O to P, we have specified that it is from origin. From origin minus 2, right? 1, 2. And then 5 units up. 1, 2, 3, 4, 5. So that becomes the vector OP, right? So this is O and this is P. So that is how you will represent OP, the position vector. Is that clear to you? So on a coordinate plane, OP is a position vector. Now here we have a displacement vector from A to B. So this is also in R2. So let's first see what is A and what is B. So when we say displacement from A to B, A is 2, 3. So 1, 2, 1, 2, 3. So that's the position vector OA, right? And B is 0, minus 3. So 0 and minus 3 means 1, 2, 3. So this becomes B for us, 0, minus 3. So from A to B, the vector is drawn as A will be the tail and B will be the head. So kind of like this. So that becomes the vector AB. So this is tide vector AB, right? And actually speaking, this vector tide vector could be written as this minus that, which is minus 3 minus 3 will be giving us minus 6 and 0 minus 2 as minus 2. So if you look from this position, you have to go 2 units left and 6 units down to get to this position. Do you understand? So AB is this vector. Perfect. So that is a tide vector where tail is at A and head is at B. So hope this concept is absolutely clear. Let's move on and take question number 2. Draw a geometric vector with each bearing. Now we have two types of bearings. One is true bearing and the second one is quadrant bearing. So normally when we say bearing, true bearing or just bearing, then the default value is always true bearing. Okay. The first one is velocity of 2 kilometers per hour at a bearing of 40 degrees. So 40 degrees means from north will go 40 degrees and the length of the vector will be 2 kilometers per hour. So that is how it is going to be shown, right? So let's call this as V. Perfect. So this is your east and this is your north. B. Velocity of 4 kilometers per hour at a bearing of 300. So 300 is the degrees from north. So from north 300 will be kind of like this, right? 60 short. So that will be your angle, right? So this is how you're going to represent. So this is 300 degrees. So from north clockwise. Is that clear to you? Then we have velocity of 1 kilometer per hour at a quadrant bearing from south 70 degrees west. That means, now this is south for us. North, south, east and west. So 70 degrees west. So from south 70 degrees west. 1 kilometer. So the length will signify 1 kilometer. Is that okay? So that will be your quadrant bearing from south 70 degrees west. Next one here is velocity of 1 kilometers per hour at a quadrant bearing of north 50 degrees west. So from north 50 degrees west will be from north 50 degrees west. Clear? So that will be the angle. So that is how, and this will be 1 kilometer. So the length will represent 1 kilometers per hour. That is the magnitude. So I hope this is absolutely clear. So that is how you should understand how the two bearing angles are treated when we are drawing arrow diagrams for vectors. Let's take question number 3 now. Question number 3 is relating conversion of bearing angles from true to quadrant bearing and from quadrant to true bearing. Question number 3 is, write a true bearing of 120 degrees as a quadrant bearing. So let's try to understand this. So when I'm saying true bearing is 120 degrees, that means the angle from here 90 and 30, right? So that becomes, so this is 120. So this is 90 and this is 30 degrees, correct? So that is 120 degrees. Now if I have to write this as quadrant bearing, I will write this as, I can write this from south, we are going towards east and this angle is 60 degrees. Does it make sense to you, right? So the true bearing is 120 degrees. Quadrant bearing is from south 60 degrees east. Does it make sense to you? So that is how we could equate them. Now here is for you question number 4. Write the quadrant bearing south 20 degrees west as a true bearing. So you can actually pause the video now, answer this question, then look into my suggestions. South 20 degrees west. Right? So if this is 20 degrees, then how much is it from here? This is what you have to figure out. It is 180 plus 20, right? So from north, it is 180 degrees plus 20 degrees, which is 200 degrees. So here the bearing angle is, we can say true bearing angle is 200 degrees. Is that clear to you? So that is how you could convert from one bearing type to the other. Question number 5. Describe a vector that is opposite to each of the following. Now, to solve many questions, we need this concept. So how do you define opposite vectors? Opposite vectors have same magnitude and opposite direction. So basically we are looking for same magnitude but opposite direction. Okay, so 30 kilometers per hour on a bearing of 200. So if I have to make 200, it will be 180 plus 20, right? So 30 kilometers. The opposite to this will be on this side, correct? But same magnitude. Now since this angle here is 20, right? This is 20, that has to be 22, right? 20 degrees. So in this case, when we have to write this as 30 kilometers per hour at bearing of 20 degrees. So that is the opposite vector. Is that clear to you? So that is how we get the opposite. So when you add them up, you get zero vector, right? Let's do the next one, which is force of 40 newtons at 30 degrees to the horizontal. So let's assume this to be the horizontal x-axis now. Is it okay? So 40 newtons at an angle of 30 degrees, that becomes your angle. So equal and opposite vector will be in this direction, right? Coming in this direction, so it is going to be this much. Where again, the angle here will be vertically opposite, 30 degrees. So that becomes your angle. So we could say the force is 40 newtons, and that could be described from south, it is 60 degrees west. You could do like this. Is that clear to you, right? So from south, 60 degrees west. That is how we could describe this particular opposite vector. So I hope with this exercise you clearly understand how to represent vectors. So they could be represented by words, in words. It could be represented on coordinate planes just as we saw. They could be represented with geometric vectors in free space with arrow diagrams. And when we are doing it with arrow diagrams, we could also use the concept of bearing angles. Bearing could be true bearing or it could be coordinate bearing as we saw in our examples. I hope that helps. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.